All right, so today we're going to look at 5.2, which is evaluate and graph polynomial functions, and we've been doing that already. We've graphed linear polynomial functions and quadratic polynomial functions, but we're going to graph all kinds of polynomial functions in this chapter, and we want to see what their general shape is in this lesson. So this is 5.2. There's two things you're going to do for me in this section. First, there are guided notes already in Classroom, so you can pull this up so you can go guided notes with me. If you want to write your own notes and use what I write here as a guide, that's fine too. It does not have to be on this piece of paper. We also have posted in Google Classroom an 8-minute video from Sal Khan who describes what end behavior means. And he talks about the growth of functions as the exponents get bigger. So we did exponent rules in 5.1. That was here. We need those to do what we're going to do today. So that's why that's 5.1. And now we're in polynomial functions in 5.2. So let's define all of these words. That's why I put them here so I wouldn't forget. So monomial means one. That's going to be there's one term in the function. Okay, so one term in the function. Poly means many. So back up here. Mono equals one. So that word mono means one. A polynomial function is going to have many terms, but specifically a polynomial, in those terms, the exponents have to be positive exponents. I got a little ahead of myself. Trying to talk and write. So exponents must be whole numbers. That means they must be positive and whole. So they can't be fractions. No fractions. And we're going to learn about fraction exponents soon and what that does to an equation. But right now, we're going to look at polynomial functions as several terms. So that's what poly means, many. And the exponents must be positive on whole numbers. And if we know that we will be able to tell exactly what the shape of an equation is based on those things. And that will come from the degree of the function. So degree means the highest exponent. So far, we've looked at equations like y equals mx plus b, where the highest exponent is x to the first power. So this would be a first degree polynomial. And we saw y equals ax squared plus bx plus c. This time, the highest exponent is the square right here. So the degree of the function is going to be the highest exponent. The leading coefficient is the quantity or the number in front of the highest degree. So if we have y equals 3x to the fourth plus 14x, the degree for this is 4, and the leading coefficient is the 3. It's the number in front of the highest degree. And that's going to be important for our end behavior that we'll talk about soon. A constant function means that it's always the same number. So a constant function, y equals 4, that's a constant function. Here it doesn't matter, no matter what x is. Y is 4. So these constant functions are always horizontal lines. And this one crosses y at 4. A linear function is the one where we see y equals mx plus b, where we have the degree is 1. Linear function, it makes a line. A quadratic function is y equals ax squared plus bx plus c. The degree is 2. In the linear function, because the degree is 1, it will only cross the y-axis once. It only has one possibility there. But a quadratic function could cross twice. So that degree 2 also indicates how many times it could cross the y-axis. A cubic function is going to be a third degree. I'll write that first. So we're going to say this is a third degree polynomial. So it's going to be something like y equals x cubed. Cubed is a positive whole number, so this is a polynomial equation. And its graph, just so our notes are pretty, this is a very tiny graph, but it kind of looks like it kind of has the same look to it as a line, but it has this wiggle in the middle. And I'm going to start to call this Saturday Night Fever, like the dance moves from the movie. So Saturday Night Fever. It's a fun way just to remember that. A quartic function, this looks like quarter, which is in fourths. So this is a fourth degree polynomial. So fourth degree means it's going to be x to the fourth power. It kind of looks like a parabola, but often it has some sort of wiggle in the middle and will actually look like a W. End behavior is, it describes what happens at the end. So end behavior tells us about these arrows at the end. So if you look at this one that I'm pointing at, the arrow on the right goes up. That means that y is going up towards infinity when x goes in this direction. And if you go this way, y is going up as x goes towards negative infinity. So this describes what y does as x goes to infinity or as x goes to negative infinity. So this arrow here is, we're going to call that goes. That's how we describe x goes to infinity or negative infinity. Okay, so we've written down definitions for a lot of things. You're going to want to review this, and as we talk through these next examples, what they mean will start to make sense for you, I hope. Okay, so the next section, we've got some examples already written out. We've got f of x, and this is 3x squared plus 4x plus 7. It has three terms, specifically a trinomial. The leading coefficient, first we have to find which of these three terms has the highest degree. That's this one. So this is the leading term. The leading coefficient is 3. The degree is 2. That's the exponent. 3 is the quantity of that exponent. Given the degree, what type of function is it? So since this is a square, this makes it a quadratic function. So we're going to call it a quadratic function. This next one is g of x equal to 4 to the negative 2 plus 6x minus 12. Is this a polynomial function? It's a different question. And we would say no, because negative 2 is not a positive exponent. And we will learn soon what that does to our equation, but it totally changes the look of this graph. Polynomial graphs, this graph being x squared would look like a parabola. We've done that a bunch of times, but polynomial graphs are always smooth and curvy, except for the line, which is straight, but that's a straight curve. Is how mathematicians describe it. This is curvy, this one's fat and curvy, the W is curvy, they're all smooth and curvy. So I can add that to polynomial. They are smooth and curvy. So when you see things, oops, I added that up here, now you can see it, smooth and curvy. When you look at some functions, you'll know they're not polynomials because if they have sharp points, they can't be a polynomial. Also, what should I add up here? They are continuous. You can draw them without lifting up your pen. So extra stuff for polynomial functions. So does the negative 2 exponent fit the rule on page 337 that exponents are all whole numbers? So if you remember, whole numbers means that they're the first numbers that you learn to count with. So 0, 1, 2, 3. Whole numbers are positive by nature. So this also means they're positive. If we wanted to include negative whole numbers, we'd call it integers. What's the difference between an integer and a whole number? Oh, I just told you that. Integers include positive and negative whole numbers, where a whole number is rounded to the ones place. Okay, we've already done some function notation, but we want to look at direct substitution. So some of your homework today has you using function notation for direct substitution. Here we have, this is a cubic function. It is cubed, x cubed makes it a cubic function. We want to find out not what f of x is, where we have x's everywhere. We want to find out what f of 2 is. So f of 2 says, instead of writing x everywhere, you're going to write the same equation out. But instead of writing an x cubed and negative 4x, I'm going to plug in a positive 2 and do the math. That gives me 2 cubed, which is 2 times 2 times 2, or 8, minus 8, plus 2. That means that f of 2 equals 2. 8 minus 8 is 0 plus 2. Also, this is a point. The input is 2 and the output is 2. Function notation returns a point. F of negative 2 says rewrite the equation the same way we just did. So something cubed minus 4 times something plus 2, but this time we're plugging in negative 2. I like those parentheses. It gives me a place to plug in the numbers. This means negative 2 cubed, so negative 2 3 times, which becomes positive 4 and then negative 8. So this first one is negative 8. 4 times negative 2, negative 4, negative 2 makes positive 8 plus 2. These cancel again and I get 2 out. So f of negative 2 is also equal to 2. And it makes the point negative 2, 2. This is the input, or x, like f of x, and this is the output, or y. F of 0 means rewrite the equation, but everywhere you're going to plug in 0. That's 0 minus 0 plus 2 is 2. I have 3 places where it's 2, and so f of 0 is 2. So direct substitution means rewrite it and substitute the number. You could do f of anything. You could write it like star. You could say f of star. That could be substituted in. That would be star cubed minus 4 star plus 2. You just put the star. You put whatever the input is everywhere there was an x before. So there's no, we use letters, but there's no rule that you couldn't substitute it for something else. This is a variable. It could be a monkey face. It could be, what's the function monkey face cubed minus 4 monkey face plus 2. You could totally make that be whatever you want. Substitute it for some other symbol that means a placeholder. But these had actual numbers, so we needed to evaluate them at those numbers. All right, so on this side, you should watch the Khan Academy video. It's going to make this chart make a lot more sense. So this is a chart taken directly from your book, and it talks about end behavior. So it's talking about on the XY axis. On the XY axis, if we go in this direction, so we're going on X, This is as x goes to infinity, what happens to the y value. If you're going in the other direction, so you're going this way, this is as x goes to negative infinity. So it tells you direction on the x-axis, what's happening. And with that, whatever function you graph, you're going to talk about the y-axis. So let's look at what they have in the book here. And if you printed this, you can write directly on it. So this is odd degree, meaning that this represents, we're going to call this Saturday Night Fever. It's something like x cubed or x to the 5th or x to the 7th. So degree odd. It has an odd degree. What will happen with odd degrees, and he's going to explain it more in the other video, is that as we move to the right on x, the y is going up. So you can see it, f of x goes to infinity. F of x is the same thing as y as x goes to infinity. So as x goes to infinity, y is also going to infinity. And here, as x goes backwards to negative infinity, so we're going this way, note how the function goes down. So as we move this way on our function, we're going down. So they say that f of x, or the function, goes down. I'm going to call this y for the most part because I think that makes the most sense. All right, so that's odd degree. Then below in our chart, we have even degree. So we did a lot of this with quadratics already. We said that if the leading coefficient was positive, like x squared, and this is actually to the 4th power, so this is some graph like x to the 4th. I don't know how it's been moved around, but it's an x to the 4th graph because it has this W shape to it. But if the a in the front, so if I squeeze a little a in there, is positive, both ends go up, just like a quadratic. That means that as x goes out, the y goes up, and as x goes to the negative infinity, y also goes up. But if you make it y equals negative 3x to the 4th, so a negative in the front, just like with quadratics, then this W shape goes down. But notice they have the same end behavior because it's even. So anything that has an even power, like a parabola or a W, is going to have both ends going in the same direction. If it's an odd degree, so we had y equals x to the 5th, then they go, one goes up and one goes down. And that's just like a line too. A line being an odd degree, it's y equals x to the 1st power, that's odd. One side goes up and one side goes down. So looking at this example, we have the degree of another 4th power. What is true about the degree and the leading coefficient? So the degree, because they're going in the same direction, must be even. So it's not these. The degree is even. They're going in the same direction. The leading coefficient must be negative because it's going down. So this is D. Okay, so your homework, your practice for today has you looking at polynomial functions such as this. They want you to first write it in standard form, which means you need to switch and put negative 14x to the 6th first. The highest degree goes first. Highest degree first. Then you follow with 3x to the 5th plus 2. And notice we skipped some degrees, but that's okay. So highest degree first. Now we can say that the degree is 6 and the leading coefficient is negative 14. So we know that because this is even, it goes both in the same direction, and because this is negative, it's going to go down. This one's going to have more wiggles than an x to the 4th graph, but we know about end behavior just from those two things, which is really cool. If you have one where you don't have positive numbers up here, so if you had y equals 3x to the 1/2 plus 2x to the negative 2, both of these exponents would break it and not be a polynomial function. So this is not an integer, and this one is not a positive integer. So if either one of these are present in your equation, it's not a polynomial. So this is not going to be smooth and curvy and continuous everywhere because of these two exponents. So this one is not a polynomial. So your practice today is telling what kind of function it is by the degree. We haven't named anything above 4, so neither of these we would give a name to. But we can name functions that have degree 1, 2, 3, or 4. So linear, quadratic, cubic, or quartic. So that's part of your work for your practice. All right, work on your homework, watch the Khan Academy video, and we will continue with this tomorrow. See you then.